Yes,
So this is the cost.
it's recording
Money
from there. Okay.
very expensive. I will show you in a few slides later, right? The most existing solutions, you will either Google Cloud, right? Either you are using proprietary solution and vertically integrated with NVIDIA solution, right? So that's why the cost is extremely high. Okay, here's another is the graph to show you. Okay, initially cloud is cheaper, easy to use, and in the beginning you don't have lots of you develop models on your laptop. You try to play with, find out how many GPUs and resources you want to use. So Google AWS Amazon.
Okay. I think that's right.
It's good. But when you come to a certain point or inflection point, right? So at that time the cost will be very high, right? So then you have to make decisions because when the model you're training 24/7, right? Large data sets, data moving out, all the things, right? Cost a lot, right? So this is the then become solution
because of the microphone recording is not as clear with the echo right now.
That way you can totally control the cost, right? So this graph just show you
I can be closer.
how much investment is not wrong. Okay, cost effective. Regardless, I will show you the few examples. Okay, for example, for this, for example, for NVIDIA GPUs, H100, right, and the 122 terabyte data storage, performance monitoring, intrusion detection, right. For us, we selling for 350K, right. So NVIDIA costs 700 more because they don't have full GPU configuration. The minimum will be 8 GPUs. So regardless, you have to pay more for the DGX, right? So for Amazon AWS, it costs 38K per month, right? The Google's cost 34 per month, right? So this is just the numbers there. So here's a breakdown. Okay, breakdown for the AWS, right? The compute is 35K, storage 2,800, intrusion detection 100, performance monitoring. So the cost will be 38K, right? 38K. So that is for 4 NVIDIA H100 GPUs, 122 terabyte of data storage, and performance monitoring and then intrusion detection, right? Capabilities, right? So for the Google, it's the same, likewise, right? Compute 31K, storage, 2,400, intrusion detection, performance monitoring. So that is how much Google costs. So let's do 8 GPUs, 8 NVIDIA H100 GPUs, right? 500 terabyte data storage, performance monitoring, intrusion detection, right? So we send 500K. So NVIDIA will be 700 and more, right? 700 okay, because not just vertical integrated solution, also NVIDIA doesn't provide the data storage. So you have to use the NVIDIA certified partners like Pure Storage and NetApps or Dell UNC. That costs much more because of the license, because support is much more than 700K. Okay, here's an example. But for Amazon, it costs 84K per month, right? So for Google costs a little bit less, but still same. So what he says is very expensive is on the cloud. Right? If you use like for example, 10 months you already have own your own infrastructure. You buy from us. Okay, here's a breakdown, right? This is the 8 NVIDIA H100 GPUs, 500 terabyte of data storage, performance monitoring, and intrusion detection, right? So you break down, we'll see compute, 71K, storage 11K, right? Performance monitoring, intrusion detection. Just the data transfer costs you $800 per month. This is very expensive. Yeah, Google's likewise is the same, right? compute, networking, all that. So talk about cost of savings, right? So in 3 years, right, if you're using cloud, right? So and the versus using our cluster, that means you can save $9 million in 3 years. Okay. Here's all the breakdowns of the hardware, right? The cost. So this is for 32 NVIDIA 800 GPUs, 500 terabyte of data storage. Okay, so if you see that one means cost a lot, you buy from us, less than $3 million, right? But for Amazon, you will have 11 million in 3 years. Okay, so that's the cost. So likewise, just if buy NVIDIA cluster H100, let's say 32 NVIDIA H100 GPUs, 1 petabyte of data storage, right? Compare with us, you still save $1.2 million, right? So same kind of GPUs, same kind of data storage, you save money. So, okay. Power savings. Power is a big issue, right? So for DGX H100, the power minimum use is 10.3 kilowatts, right? And then, we break it down from our cluster is about 75 kilowatts. So you save like 2,000 per year. So power savings, right? If you have more, more GPUs, right? Like 128 GPUs, here you will save more power, right? Minimum is $6,000 per year. Here's all the breakdowns for that. Okay, so then you will ask why you can save money, right? So the main things here is the difference is that we're using industrial standard components, industrial standard systems. So what that means, we can use different kinds of let's say systems, right? We can use Dells, we can use HPs, or even we can use Supermicro. For these systems with the GPUs, the system fully certified by NVIDIA. So you should use the same software, whatever you use there. But all the rest, because of that, like for example, like switches, right? We don't have to use Monoliths, the switches from NVIDIA. Right? We can use, right? So there are many ways we can reduce the cost, right? So because the components it's not vertically integrated, right? Like for example, like drives, these small drives, and you always can exchange very easy because it's industrial standard, right? It's proven the components existence in the testing and the support. You have a variety of the large network, right? And the cost efficiency. Why cost efficiency? Because we can multiple sourcing different vendors. Which one will be have a good price. We can use that one, right? And of course the performance, and also you can simplify the maintenance, right? So you don't have to, because the components is easy to get, but except the GPUs, right? You use the place are not so easier, right? Of course, then because the design you can do end-to-end integration, so the systems whole rack or clusters can be very efficient, saving power, for example, right? So this is why cost will be lower. If you compare with vertical integrated like NVIDIA's, right? Or you compare with cloud. So here's the reason. Okay, so the other thing is that if you see AI networks, right? Usually have composed of networks. You have a control plane, a management plane, you have a compute network, you have storage network, you have EMC monitoring network, right? So what that means, you have all these separate networks. You need a separate router switch to routing the traffic, right? And then adding the complexity, using more network equipment, right? Use more energy, right? Slow down jobs performance and high total cost. But for us, we merged 3 to 1. So we only have 2 separate networks, right? So we merge the computer management and the storage into one network, right? So there's no routing the traffic between the computer to storage, right? And so 2 separate networks, so we reduce the complexity, right? We use the network equipment, we use less energy, and you improve the job performance, right? So you lower the total cost. So for this end-to-end innovation, there are lots of innovation you can do, to save, not just save time, save the cost, save the money, but at the same time, you can improve AI performance training or inferencing, right? So this is the area, I don't think lots of people pay attention. So here is the layout of the design of the rack, right? When you buy the product from us, you got this, right? So the bottom one is the storage systems, servers, and the other 2 will be compute nodes, right? The NVIDIA GPUs, and this 122 terabyte storage, and the rest will be empty when the resource you need to increase, to scale. Then we can just select the machine, right? And on the top is the Quantea connection, is the smart switch, direct the traffic, to the storage nodes and the computing nodes. And also the second one is the Quantea QAI. That is the one cluster manager and the performance monitoring and the intrusion detection. So everything is there, the RDS. So this is the layout of the rack. Okay. So here is one fully packeted rack, right? Basically, those will be one use, right? And also storage server. So we give customer flexibility of the pick choose what kind of GPUs, right? It could be A100, F100, Air40S, B100 GPUs. And also the data storage is flexible. The customer wants to have large capacity, or you're not worried about performance. You always can pick choose the SSDs or NVMe, all that different kinds of drives, right? And likewise, customer can pick choose the operating systems, Ubuntu, different versions, and the CentOS. These 2 are most dominant operating systems, right? So we give the customer lots of flexibility. So here is 2U nodes. Right? 2U nodes means each node has 4 GPUs. 1U nodes is each node has 2 GPUs. This one node can have 4 GPUs, right? So everything is the same. Only difference is the GPUs inside on machines. Okay. So we also doing AMDs and GPUs. So also it's the same, but it's just picking different GPUs from AMD, right? MI 300, right? MI 250X. So depending on the customer, what is there specifically for their AI projects. Okay, so let's talk about the Quantea condition, right? So this is the cluster. So this is the smart switch, right? Distribute the traffic into multiple computer nodes, distribute traffic into multiple storage nodes. Okay, so we also have dedicated the out of band traffic into Quantea QAI for network analytics for the performance monitoring and the intrusion detection, right? So this is this is the congestion diagram, diagram. So for this for Quantea QAI is the performance monitoring intrusion detection systems, and also is a cluster manager and workload analyzer for AI, right? So this is the minimum at 400 gigabits per second, and the RAG EV2 and RDMA monitoring of the packets, and also expanded. There's capability have long-term retention of the data. Let's see, the customer want to see past 3 months or 6 months or maybe a year, what happened to the cluster? Is this the performance, the conditions, is there a security risk? Maybe some attack with malware, all these history logs we can keep for this, for this cluster conditions. So initially, we can go back audit to see what's going on, right? So that's very important capability for this monitoring systems. Okay, so when you buy a cluster from us, so we say it's all-in-one convenience, fully integrated, pre-configured. What that means, when you get the cluster, it almost like plug it in the play natural. What that means, you get a network configured, control server connected, like DNS namespace is configured, provided, and set up figures for network traffic and ready to analyze network data, right? For almost, right? So if you don't buy from us, you buy from any vendors.
Okay, good.
You need a high consultant.
If there are good questions.
Because this is very complicated setup, very demanding. You gotta pay a lot with the consulting agencies for you. You need a different expertise in networking, AI networking. I'm talking about, right? AI data storage and AI systems, all that things costly, right? So that's what we can provide for for any customer if they interested in our cluster. Okay, so the other thing is, let's see if the startups, some company they don't have a server room, they don't have data, data center, or maybe they even have a data center, they don't want to manage it. They can offload, let us do the job. We can do for them. We can host it for you, right? And we can support for you. So basically, you own your network infrastructure. It's yours. You own that, right? But we manage it for you. You can remote dying. You do whatever you do, training or inferencing, right? But it's not a cloud. But it's your own property. It's your own things, right? So we also can do for you. Okay, because this is NVIDIA GPU, right? Or we call it NVIDIA's. So all the NVIDIA softwares, it's 100% compatible. You can use, you can move the models trained there, inferencing in this cluster. Okay. So the other things we got feedback is some customer they don't want to just do training, just doing inferencing. You want to do development like an agent, whatever you want to do. So all these tools are compatible. We can use for the additional development. Just flexible. The cluster you can use for multiple scenarios, multiple purpose. Okay, so that's the features. Okay, so yeah, so bring the era to every business. That's our goal, right? So we, right now the AI infrastructure is dominated by tech giants, right? Like not bigger labs, right? They have the resource, they have the money, they have to have this kind of infrastructure, right? Because the scaling laws of the AI, the models, you need lots of computing resources in order to create a model, right? So normally the business, the small business, they usually can't. They only can go to the cloud, right? So that's why the costly, it's very high. So we can enable all the companies depending on the cluster. You don't have to spend a lot. You can starting small and scale bigger, right? Okay, so features, feature matters, right? Features, affordability is number one, right? 350K, 500K, 4 GPUs, for 8 GPUs to start with, right? And then you can increase to multiple racks, the single rack to multiple racks, a hundred of nodes with many GPUs, right? So that's the scalability, right? And also data privacy, because you maintain your own, control your own sensitive data, right? This is also the issues we see, lots of customer companies, like insurance, right, like banking, they never want to go to cloud, right? So they have to own their own AI infrastructure for their own AI models, right? So, and the building performance monitoring, optimization, monitoring workload in real time, right? And then intrusion detection, security. It's very, very important features there. Yeah, so tailored to needs. What that means, you have options to choose flexible hardware, as I mentioned. From GPUs, you can choose all different kinds of GPUs. From operating system, you can pick and choose different operating systems. The storage size, the performance, you can pick and choose, right? And so this is the very, very flexible for the customer. And then starting small, so scale big, right? Starting from 2 nodes, 4 nodes, to GPUs, 8 GPUs, to many nodes, many GPUs, right? So so basically, this is good for starting. You can later you can scale, right? Infrastructure can grow in tandem as your AI demands increase. Right? Without compromising performance and the security. Okay, affordable, I will show you. So one-time investment, you don't have to worry recurring costs for the unpredictable cloud, right? So that's the affordable and also scalable. And so customer solutions, that means we for any customer, right? As long you have the AI projects, we are here for you, right? You can come to get our systems, or we can serve you. So this doesn't matter you're from financing or telecom or insurance or manufacturing, right? So for different companies, different customers you can do. And then so security, right? Intrusion detection. So the system we have lots of good features integrated into this performance monitoring, intrusion detection in this cluster, right? So focus here just these a few features, right? So you can protect the data, transfer, detect the unusual data, transfer the things, right? And also especially we can monitor the model artifacts, right? Like let's say monitoring, training the data model weights, right? All these files, the configuration files. So this is very critical. The changes matters. So you can keep the monitoring for that. And also, you can, you need to do the audit, for compliance, right? So, and also advance the threat deep packet inspection means we really go to the packet level to analyze what's going on in the AI network. Okay. Also, detailed forensic instance response analytics, right? What that means, as I mentioned to you before, right? We can retention. We can have keep your all the let's say past 3 months, have year or years the data logs. What happens, right, for the attack, for the security and for the performance. So this will be very very important for most of the customers. And then performance monitoring, intrusion detection. Performance monitoring means we can do lots of monitoring at the packet level, right? So lots of details that I'm making to you, such as RD, RACV2, RDMA traffic. This is a new kind of the networking communication protocol, specialized for AI. We are expert for that. Okay? We should balance load, keep the system flowing, right? Minimize the delay, the jitter. Lots of features you can have. All right. So the other thing is the customer wants more about additional consulting. Okay, orchestration, right? Management setup, such as the Kubernetes, you want to do more about the configuration setup, you're more careful, we can do for you, right? For the containers. For the bare metal scheduling, we have to have you set up. Usually the Slurm is one of the tools, right? That we use for most of the AI clusters, right? And others. And the other thing is very important is the data storage. Storage is a big deal, right? The performance, the capacity, right? So it's very critical for AI model training and inferencing, right? So we can help you set up all kinds of file systems, such as EFS, HDFS, CF, B, and GFS, right? And Luxshore, right? All that we can do, we can help you, right? Because it's a very complicated cluster technology, very complicated applications. So for that, right? Here is the comparison, right? What we are better, right? So if you're looking at features, right? Affordability, all-in-one convenience, building security performance, right? Performance monitoring, scalability, networking analytics, right? Data storage. We have all this, but NVIDIA doesn't have, right? But cloud has, right? And but costly, right? It's scalable, but it's costly. Data storage, yes, right? Cloud provided, but at a very high cost. So, okay, so basically, as I mentioned to you before, right? AI environment, AI network, or AI setup. It's totally different than in the traditional network, right? Traditional network setup, the technology, the setups, it's totally different than AI, current AI infrastructure, right? Here is the example of the networking, right? If you're looking at the traditional IT infrastructure, right, it's a control user access. It's a north-south network, right? And also it's a loosely coupled applications, TCP/IP, TCP, low bandwidth, low flow and utilization. The TCP protocol is a primary protocol, right? It's a high jitter tolerance, right? Over subscribe the topology and the heterogeneous traffic, statistical multipassing, right? But if you're looking at AI infrastructure, and the network is totally different. It's east-west traffic, right? Tightly coupled with the process. And the RDMA is the primary protocol, right? Low jitter tolerance, non-blocking topology, right? And bursting network and capacity predictive performance. So this is totally different. So that's why you need a special different kinds of skill set or technology technical expertise here, right? So the key measurement of the AI optimized network is just how long AI training jobs takes from start to finish. That's the measurement. All right, so yeah, we can do additional, consulting. We can help you to migrate from cloud to on-premise data storage. We can do additional. We can help you design, create the your favorite AI infrastructure for you. It's just it's like a consulting service. We can do for you. And then we have some award, from 5 years, from Santa Clara, best software and the networking company. Okay? We are the partner of the for AI infrastructure. Yeah. So here again we'll be talking about the we do take our points, right? One is we provide a variable AI infrastructure alternative to NVIDIA's and the cloud solution. Right? So 30% or 50% money savings, right? And the on-premise AI infrastructure is cost effective, right? So basically avoid cloud subscriptions and protect your proprietary data with on-premise infrastructure, right? And also it's scalable, right? From the seamless from 4 GPUs to many GPUs, 100 nodes, right? That's your business growth. Okay, yeah, here's the content information. Here's the, we basically, so what we do is we market as AI infrastructure for all, affordable, scalable AI cluster, to customize more options for your business. Okay. So, any questions?
Well, one of the things you said was the performance of the network cable package a lot. Done any work to compare, end-to-end performance versus other things?
You talk about the networking, AI networking.
So I want to know.
Yeah, so for our network, right, our cluster, network is 400 gigabits per second, right? Minimum 400 gigabits per second for that, the read, right? And, of course, for NVIDIA, they have, okay, for the cloud, surely we are better than cloud companies. Cloud is very slow, because the network have 400 gigabits per second. Maybe, I think, 40, even not that. So it's not, it's not comparable with the cloud, right? So only comparison is with NVIDIA vertical integrated, right? So they are also 400, mostly it's 400 gigabits per second. The later version, newer ones, like a B200, right? Newer GPUs, your GPU can achieve more than 400 gigabits per second. So, but for us, right, our purpose is mostly focus on the relatively cost savings, right? So you do have some compromise. If you're only looking for high performance, right? So maybe it's good just buy NVIDIA's. No, I mean they can because they are vertical integrated, right? So even that, and you still even though maybe it's not happy, right? So what I heard is one of my friend of mine, he told me like Meta, right? Meta bought lots of 100 clusters, right? People heated that because the reason is just one cluster failed. We have to reboot all the clusters, like that. They try to slowly try to fix that's reality. Even you pay the money, you will not get it very good performance sometimes.
Inflection point. What's a common number?
Yeah, I think I have one. I put
Way in the beginning.
yeah, at the beginning, yeah, there's no. Okay. Yeah, I think I'm missing one slide here. Hold on. For some reason, it's it's about the like the inflection point is about 150. If you pay 150,000 per month, then that comes serious. What happens? All the enterprises have the serious consider. They want to go to the on-premise solution. Okay, that's a inflection point. I have a slide for some reason. This here.
That's a pretty important slide.
Yeah, I have a slide. I don't know if it's there. I can show it. Okay. This one works. some reasons, I don't know, I don't know why. So one page is missing. Yeah, yeah, it's about 150K.
Spend that initial inception in on-frame cluster is paid, right? The cost in, but then over the period of after 2 years, you want to go and upgrade, right? Your cluster, we need to upgrade them, right? And so is that something remotely your team can do the upgrade,
Yeah,
or
so-
it has to be?
Yeah. So, okay, on the cloud, right? You just click, you can upgrade, right? You can change
Right.
different GPUs, different instance, right? For example. But for the cluster, because this is hardware based, right? For example, you want to migrate, let's say, from H100 to B200, for example, right? But what we can do is we can exchange the chassis, the whole systems. Because the GPU is totally related to motherboard or the computer. Yeah, we can swap.
Right. So that's another, like, I mean, I have production services running.
Yeah.
And if I rank, then basically there is a
Well,
downtime impact or.
no, there are number of
there is
ways.
a-
There are number of ways you can do that, right? You can set up several rack.
And then.
Yeah, you can test
Fail over
out and
them.
migrate, right? So yeah, there are always puzzle.
Yeah, that's, so if I don't want to go on-prem.
Yeah.
And still want to go ahead and what you are hosting, right?
Yeah.
So is the numbers are still comparable, right? If you are hosting, right, and I'm going to do a subscription.
No,
Based with
okay.
your,
It's not subscription.
it is one time,
Yeah, it's one time. It's yours. Your cluster. It's your own.
but it's hosted by you,
Yeah,
your data center, right?
We host the let's see, like Iconex, let's see, or maybe co-site, right?
Okay,
So that means it's you still own, everything's yours. Or we can help you support, upgrade. Yeah.
so the cost wise still it's comparable,
Oh, yeah, definitely.
so whatever.
Oh, yeah.
The projection you said.
Yeah, comparable, yeah. Yeah.
So, thank you.
Do you, does any company or your clients actually, supporting VPN?
Oh, yeah.
It does?
It does, yeah. VPN.
Okay, do you actually detect that? Or do you have any way to monitor that?
Oh, yeah, we do. Also, we have very good, intrusion detection systems. We have very sophisticated, for that, with the network tax data and analytics technology. If you want to, I can let my CTO explain a little bit about the RDMA, all that, more information if you want to. Maybe a few more slides, we can show you.
All right.
Maybe if you want to talk about it.
Oh, yeah, sure.
So, anyone is welcome to ask any questions. No, this one. This one. This is argument.
Nice, but anyone's welcome to ask questions at a time. I'm just gonna go over a little bit about the networking side of it. So there's gonna be a little bit of a background information about AI workloads. Sure.
So, say we have microservices.
Yep.
And then we have those deployed in AWS or Azure. And we are trying to build an LLM model on that. So then we could actually use for the microservices, different cloud platforms and also use your clusters for just mostly training the elements and building the elements. And then will they be able to interact, like, can I say, AWS can call them your clusters?
Oh, certainly. Yeah, because for hybrid cloud solutions, you can have heavy, compute heavy workloads be handled on-prem,
Okay.
where you can have some of the smaller microservices being handled on the cloud. So because there's some, I would say some key advantages with some of the applications that are running. Yeah, thank you.
Thank you.
Okay, so just a little bit of a background regarding networking of, AI cluster workloads. They create petabits of data on a regular basis. We deploy some solutions that are generating, under 10 petabits or petabytes of data. One thing that we're focusing on here is, RDMA over converged Ethernet. So this is RockE V2. And these are predominantly in, data center environments, cloud environments. Unlike, just InfiniBand in RDMA, those are typically in HPC. Environments are, kind of limited in terms of the number of nodes. The main difference with, I would say, Ethernet and InfiniBand is, Ethernet has IP, so you can extend beyond 9,000 different devices as opposed to InfiniBand, but you could do workarounds with InfiniBand as well. But so we're going to go over a little bit about, AI workloads. So for RDMA, typically bypass the kernel, in the network stack. So, like Linux kernel, in this example, so you can interact directly with the GPU, using, via the network. And, there's a Ethernet, option for that, which, we do, implement in our clusters. So the thing is, what Nan mentioned earlier is that, when it comes to, Ethernet, is that, and also IP, it does become more open to security issues. So, this security gap is typically not addressed, which is very interesting. Even today, you can see that, on the very right there, 95 out of 100 still operate AI workloads that are completely unencrypted. So because for the sake of convenience, a lot of these companies still transfer data without the use of encryption because they don't want to have performance and convenience over security. So that's kind of like the mode of operation. That's kind of like the reason why it's not addressed at this point. And some of that data that's being exchanged might be susceptible for interception. A couple of things is like, for example, host memory addresses and contents are exposed. So someone can just do like an injection, for example. Again, some stuff in the RDMA is not encrypted. And there are different types of attacks that can take place. Injection, make congestion, disconnection attack, and resource exhaustion. So just one example, this is actually an interesting thing that I saw on the internet was for example, you're sending an email to to your manager asking for a budget, for example. You can actually insert like a text that's like invisible in the email. You could just have a font that's like in an invisible color, like white. And then you could inject like a prompt in the bottom of the email. You could say, you can if the manager is using AI to read the emails, they'll probably just say the stuff on the bottom that's invisible. So it's kind of like similar thing happening here, but it's on a cluster side. It's on the workload side. So pretty much with different types of injections, you can have a user space application, being able to get things exposed, and then that will cause some security issues, pretty much. So a little bit about the different attacks that can happen with AI workloads. You can have unprivileged users, especially with like AI training data. You can have let's say files, images that are exposed, and you can actually inject false data onto there, and that could be depends on what motivation the hacker or the perpetrator would have, but that's the way you can pretty much propagate an exposure into the system. And also another thing is fake congestion because RDMA or over converged Ethernet, it does have something called PFC or congestion control parameters where you can actually that's used to predict whether there's a congestion that's about to happen, and the network will try to compensate for that situation. So there's things that you can manipulate to cause I would say a disruption in the production service of a network. So and also a lot of these things can lead to resource exhaustion as well. So essentially blocking certain services from happening. So this is like an example here for impersonation by packet injection. You can create different parameters because this is all open. This is all you can actually intercept the traffic in the middle, and you can see these values like the PSN, PPN values that are actually in plain text. You don't actually need to decrypt them. So you can go ahead and you can actually play back the traffic onto the network, and it would get routed on the switch. And again, this is another thing that would cause it is remote code execution. So if you have things that are pretty much open-ended, there's a chance of jobs that are being allocated without prior authentication. So there's very much a lot of things that could be done, especially if the hacker has access to huge resource such as like a cluster. So that's kind of like the reason why addressing these gaps are pretty important, because they're going to become more prevalent as the adoption for Rocky V2 becomes more popular, because a lot of companies right now, they're still using a lot of the InfiniBand. However, there's some scaling issues associated with that. Even with NVIDIA starting to promote Rocky V2 infrastructure as well. So one thing to implement is a secure queue pair. So what this one does is it's essentially imitating something like TLS in terms of like regular IP traffic. And this is what this is it's pretty much a handshake situation where it would cause the reads and writes to be authenticated. And also create a delineation between privileged and unprivileged processes, because there's tens of thousands of them running at the same time. So being able to create resources that allow these processes to access certain files, restricting them to that is going to be pretty much critical. And one of the main things is maintaining a searchable and accurate record from the network. So like what Dan mentioned earlier, being able to gain some visibility on the traffic that's being exchanged across the nodes in a cluster is going to be pretty important. So you can see here that I think this is a Rocky V2 packet on Wireshark, and you can see the different parameters. So you can use a lot of different tools to be able to see if there is things such as false congestion, or anyone injecting pretty much false reading of the network to try to cause issues. So yeah, so that's just a little bit about that. Are there any questions? Nope.
Right?
Yeah, sure.
When you say the encryption happening, right? So you have or TLS encryption. So if you have the key, So I just wanted to see what SDK or say someone who is sysadmin. And now you're saying the encryption has to be established. Now you have to rotate the encryption and all that. So how do basically in this you're giving a rack, the on-prem rack and non-habit. Right? So now someone needs to be really aware of the rotation, encryption key rotation and all. Because once you push it, then you need to maintain, rotate on occasionally for life cycle and all. So do you have kind of some kind of SDK bootstrap? The professional team can take care of it or?
Definitely, yeah. So this one is slightly different from like TLS traffic. Because what we're dealing with is just regular RDMA traffic.
Okay.
Where it's gonna be it's very much just gonna be no IP address to them at that point. So one thing is being able to implement the this secure pair. What this is a modification on top of RDMA that requires kind of like a checksum. Being able to
Okay.
make sure that what I'm expecting is what I'm gonna get. As opposed to so because right now that's actually not implemented a lot, and also there's a consortium for improving RDMA. So they're releasing something called SRDMA, which is the the S is secure, so kind of like HTTPS, so it's going to be a overhaul of that particular protocol. Yeah.
Thank you.
And thank you so much.
Also regarding the network segmentation, like network, when it comes to this kind of rack or so I want to do a public facing network / private network within this cluster.
Okay.
So do you have this kind of topology when I just provision the rack? Is it bootstrapped out of the box or like there is a private subnet, just like AWS, right? I'm coming from AWS world.
Yeah.
So you create a VPC private, and there is subnet, right?
Yeah.
There's a public subnet, private subnet. So you isolate all your business logic in private subnet, put everything what is edge side, put it on public interface, right?
That's
Public
correct.
subnet. Something similarly, you have this kind of
Yeah.
topology here.
Yeah, that's correct. So we can provide client facing infrastructure as well as internalized infrastructure as well. Because the main thing is like, for example, the processing units themselves, like the GPUs, we want to make sure that they're segmented. For example, if the same GPU is sharing the workload of a public service and at the same time training internal things. So we have the means to be able to create compartments for that. Yep. Okay. Yep. So we also, in terms of the design of the network, a lot of our background has to do with designing and implementing networks for the enterprise. So we could definitely follow up with you about that and see where
So out of the reading, I'm not really in touch with the security, but there is a lot of discussion going on the AI cryptography for the security side, right? Quantum cryptography on AI. Is that something you also get some kind of requirement from the customer?
Yeah, so the quantum cryptography is actually, I think it's already a requirement for government organizations. So that's something that that we do as well. Yep. So there's hardware processing components that we can include to do that. Yeah. The thing is, like, I don't know if it's they call it quantum cryptography, but I think for me, like when I looked at it, I don't think it's exactly quantum, so but they just call it that, so yeah. All right.
Yeah, thank you.
Thank you so much. Let's see, I think it's on the other, does anyone have any questions? Right. So you guys have any other questions?
Yeah, thank you. Thank you.
Can you
Well,
hear
we
me?
got some questions, so we answered the question. Yeah, I'll go ahead and answer it. I'll answer on the text.
This question online, I can read it.
Sorry.
The life expectancy for components and the difference for each component with the solid state devices like CPU, memory, GPU, and flash storage have operated continuously for 5 years. NTMD and FDF is rated typically at 1.8 to 2.5, no, 1 to 8 or 2 to 5 million hours. And so what's the question?
I'm sorry.
Yeah, what's the question?
Oh, so the question was, what is the life expectancy for different components in the solution?
Yeah, that's not the question. Question on YouTube. Oh, the question does come through YouTube. Oh, ready. Okay, that's I'm ready. Okay. How does Fred deal with the certain requirements? That's one question. You want to answer that one?
Yeah, I'll answer it on the text. Or should I, is it,
You just go
I think there's a little more on there. Can you hear me?
okay.
And if you can activate the camera on that would be better.
Yeah, I don't know how
We're
to.
getting better when the meeting is going on.
Yeah, I don't know how to activate the
Uh-huh.
camera here. So pretty much, the question was, how does on-prem deal with sudden requirements? And the follow-up with that is, our services typically run high for 1 hour. Why do I have to accommodate it every time? So that's kind of like the question there. So the thing is, like, sudden requirements will most likely increase in requirements. The only for our solution, I would say that as long as you have the right provisioning to deal with those requirements, typically um, for um, for deployment of an on-prem solution, you would probably have to overcompensate a little bit. So have over provision let's say the compute resources in order to meet these sudden requirements. So it's pretty much just capacity planning, being able to expect these sudden requirements, So it's a little bit more difficult with on-prem. If you're expecting a sudden change in requirement given a really short period of time. But if there is if the requirement is over the capacity of existing on-prem infrastructure, then we do recommend being able to add additional nodes that are it's pretty much pretty flexible to add additional nodes and have it scale up. Yep, hopefully that answers Tarun's question. Thank you. Okay. All right. Okay, I'll go ahead and type that answer just in case they didn't get it. Okay.
Any more questions? Can we close? Okay, thank you for coming.
I stopped the recording.